Welcome back to CIA Declassified. We pivot now from the shadows of Cold War human espionage to the cutting edge of space-based surveillance, a program so secret its very existence was denied for decades, Project Gambit. To understand why Gambit was necessary, we must look at the predecessor, the Corona program, or KH-4. Corona was revolutionary. It was the world's first successful photographic reconnaissance satellite, confirming that the US and the Soviet Union were locked in a technological race. However, Corona's imagery was relatively low resolution, often only detailed enough to show major facilities, not the precise tactical details necessary to count warheads or measure missile silo dimensions. In 1961, the national security establishment urgently needed keyhole imagery, intelligence imagery, that could resolve objects on the ground as small as 2 to 3 feet across. They were hunting for confirmation of the Soviet ICBM threat, and the resolution just wasn't there. As officially noted in a 1997 NRO historical review, the Corona systems were limited to, quote, a resolution capability of about 25 feet, which was excellent for broad area search but inadequate for precise intelligence on specific targets, end quote. The U.S. needed to see the details of Soviet missile launchers, not just the facility they were housed in. This high-resolution requirement became the mandate for Project Gambit. The initial phase of Gambit was fraught with bureaucratic friction. The program was born into the newly established National Reconnaissance Office, an organization whose very existence was classified. According to a 1964 NRO Memorandum on Interagency Coordination, there were significant tensions. Quote, the required funding and manpower diversion from existing programs, specifically Corona, met with considerate resistance from established Air Force and CIA leadership. End quote. The intelligence community was essentially forced to choose between proven, if blurry, technology and unproven, high-cost, high-resolution technology. The strategic necessity for tactical detail ultimately won out. Project Gambit, designated the KH-7 system, was a radical leap in technology. Unlike the Corona satellites, which carried multiple film recovery buckets and could operate for weeks, Gambit was a focused, single-purpose system designed for quick, high-resolution kill. The satellite itself was launched on a powerful Atlas rocket and carried a massive camera system with an extremely long focal length. The system utilized a single huge primary mirror, approximately 5 feet in diameter, to achieve the necessary magnification, a design feature that presented enormous engineering challenges due to vibration and temperature changes in orbit. The camera used highly specialized 9-inch wide film similar in size to what was used in the U-2 reconnaissance aircraft. To keep this film perfectly flat and ensure crisp focus, it had to be held against the focal plane by a powerful vacuum system. The official NRO technical history of the Gambit program describes the precision involved, saying, quote, the orbital optics package required stabilization within fractions of an arc second to achieve the stated ground resolution, necessitating a highly complex gyroscopic attitude control system, end quote. The system was designed to stabilize itself precisely over high-priority targets, known Soviet military bases and R&D centers, and rapidly expose large rolls of specialized film. The key operational difference was its lifespan. Most Gambit missions lasted only 4 to 8 days. Once the mission was complete, the satellite would execute a single crucial maneuver, ejecting one large specialized recovery capsule containing all the exposed film. This capsule would plummet back through the atmosphere and be snagged in mid-air by a U.S. Air Force recovery aircraft flying over the Pacific Ocean. The NRO's official declassification summary emphasizes the success of this high-risk design, saying, quote, KH-7 Gambit missions, of which 38 were launched between 1963 and 1967, achieved photographic resolution of 2 to 3 feet, fulfilling the urgent national requirement for detailed strategic intelligence, end quote. This quantum leap in resolution gave the U.S. unparalleled access to previously hidden Soviet military developments. The most dramatic part of every KH-7 mission was the recovery phase. The recovery vehicle, a sphere containing the film and a parachute, would re-enter the Earth's atmosphere over the Central Pacific. The operation, known internally as, quote, catch and keep, end quote, was a high-stakes airborne ballet. First, a small drogue parachute was deployed to stabilize the capsule, followed by a large main parachute. At this point, specially equipped Air Force C-130 aircraft, flying with reinforced wings and sophisticated navigation systems, would fly a precise interception course. The aircraft would trail grappling hooks from its tail, aiming to literally hook the parachute canopy and winch the capsule safely aboard before it hit the ocean. The alternative, a saltwater landing, meant the film, while designed to float, could be degraded and potentially lost. This process was so vital that according to a 1965 Internal Air Force flight manual, the C-130 recovery teams performed, quote, thousands of hours of simulated and practiced catches, often using dummy capsules to ensure a 90% plus recovery rate, end quote. Now let's talk about the missing ink. Even in the declassified histories, significant portions of the Gambit documentation are still heavily redacted. Why? The heaviest black boxes often conceal the NRO budgetary transfers and the targeting specifics. The NRO budget was, for decades, a line item entirely hidden from the public and most of Congress. Exposing the exact cost of the Gambit program would have compromised the secret existence of the NRO itself. A declassified 1971 CIA Inspector General report on program cost is almost entirely redacted, leaving only the conclusion that the program was, quote, unprecedentedly expensive, end quote. Secondly, the specific geographic coordinates of the Soviet targets, especially R&D sites and specific missile silo locations, remain classified. In some cases, even if the silos themselves are defunct, this is often to prevent the verification of how well the U.S. intelligence community had been tracking specific sensitive assets of the Soviet successor states. The redactions here protect source protection far into the future. The intelligence gathered by Gambit fundamentally changed American strategic planning. While politicians had debated a perilous missile gap favoring the Soviets, a gap that fueled military spending and anxiety, the cold hard data from KH-7 provided the truth. The high-resolution imagery conclusively proved that the Soviets, despite their propaganda, had far fewer operational intercontinental ballistic missiles, ICBMs, than previously estimated by worst-case scenarios. This capability also played a direct role in international crisis management. During critical periods, Gambit provided images that, according to a 1996 CIA analysis on reconnaissance programs, allowed the U.S. to, quote, accurately gauge Soviet intent and capabilities, preventing unnecessary escalation of tensions in the mid-1960s, end quote. In essence, the United States superiority calmed many of the extreme fears that defined the early Cold War. The success of Project Gambit was absolute. Not only did it meet its immediate intelligence mandate, but it also spurred numerous technological advancements that have since permeated civilian and military applications. The extreme requirements for mere fabrication, high-resolution stability, and image motion compensation directly led to advancements in modern adaptive optics, the technology used in ground-based astronomical telescopes to counteract atmospheric distortion. The technical brilliance required to keep the camera stabilized to fractions of an arc-second led to breakthrough in precision guidance in inertial measurement units, techniques now standard in advanced navigation systems. Gambit was not just a successful operation, it was a technological proving ground that redefined what was possible in aerospace engineering. Our exploration of declassified intelligence continues next time, but we'll leave Earth's orbit and venture into the truly theoretical. The CIA was always interested in the boundaries of science, not just what was possible, but what our adversaries believed was possible. Our next episode, we examine the shocking details of a CIA investigation into the furthest reaches of physics. We'll look at a study known as CIA RDP 80-03820A, which was a deep dive into Soviet research on gravity and propulsion. Join us as we analyze the document's findings, including the assertion that, quote, the experimental data suggests that control over a gravitational field may be theoretically possible, impacting propulsion concepts far beyond current conventional rocketry, end quote. Next time on CIA Declassified, we ask, what did the intelligence community know about anti-gravity? I'll see you in the archives.